Hey guys, I'm back again on grindleetcode.com. Today we'll again solve some problems. So first of all, I'll select company. I'll select again Google, and again we'll choose the difficulty as hard. Let's see. This problem we had done earlier. The second problem is wildcard matching. This question I've done in my second means different ID, so I'll not do this. I'll do word search 2 because this I've not done until now. So I'll go on word search 2. So okay, let's see. We have been given an m cross n board of characters and a list of strings that is in words, and we have to return all the words on the board, and each word must be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once in a word. Okay, so what we have seen until now is that we have to construct our words like this. So we can start at T, then A, then E. Then we have to check whether TAE is basically inside this or not. Or we can like see, I said TAE, but it's actually EAT, that is eat. If it is inside this, so we have to store that in a vector of string and then return this. So after reading the question, I've judged one thing that first of all, though, we have to do backtracking in this for sure. And second thing would be we need to use a trie. Now I don't know if many of you know about trie or not, but like there is a trie data structure. I'll also show you what is a trie. I've also implemented a trie, so I'll show this question I've solved. So what is a trie? That I cannot cover in this video, but this is the like construction of trie. So what I'll do is I'll just copy paste this. I'll copy paste the construction of trie, not the complete part, but yes, I have to copy this. So I've copied the part and I'll now paste it here. So our trie is constructed. So we have a struct node. Inside that we have links. So in trie, what does it happens? Like there are characters linked to each other. At first of all, I'll tell you a basic thing. So for example, we have words oath. So now how oath will be constructed inside a trie? We'll be first of all standing at a null node. We'll be asked, do you contain O? If we tell we don't contain O, then we'll create a O link. We'll create a O link, and now we'll connect this with O. Then we'll go at A. Do we contain A? No. So we'll go then connect A. Then we'll connect T. Then we'll connect H. So that is how trie will store our word. And coming on to the other word, we have P. So we'll see, does null connect? Does null has P? No, it does not have. So we'll make one more connection to P. So we'll what we'll do is we'll make one more connection. See, I cannot draw here, but like this connection is like this. From null to O and from null to P. This is like this, but I cannot show it here. So this is like a trie. I'll also explain trie in some other video, but this is not a video about it. So yeah, I've implemented trie, and this is like this. There are like some helper functions. Bool contains key. This will check whether the trie contains the current character or not. If it does not contain, then we can put that character. If it contains, then we can get that character. And there is like a two functions that mark the end. So there is a function set end. What does set end do? It denotes the ending of a particular word. And there is a function is end. What does it do? It denotes like whether the current node or the current link has a word that has ended on this node. Okay, and after this I've declared a node of root, and here we have trie, but I'll replace it with solution because our class is solution. So I'll be replacing this. I've written solution here, and there we go. We have everything required for this question. And apart from that, what we have to do is create one more function for searching, and that function would be DFS. Def for search. Why def for search? Because we'll go to each an index and start from there. For example, we'll choose O as a starting index, and then we'll move again and again, again and again. Now to search this, there are two ways. Like you can form a string like O, A, N, E, and then search that word in trie. But what I'm thinking is that will for sure TLE. Because see, first of all, I'll have to check the length of board. So I'll do board.size. Then I have n, that is board of 0.size. And first of all, I have to run a loop from 0 to m, I plus plus, and in j plus plus, and I have to call DFS each time from each index, like from this, then this, then this. So this is already O of n square. And if I make a word and then search it, then it will become O of n cube and it will not pass. Because like you can already see that will like definitely TLE. So we cannot do this. We cannot search word again and again. We have to pass node into this. I have to pass node function into this. I'll first of all create a vector of string that is gonna store our answers, and What I'll pass is, I'll pass I, the starting index, means the starting x coordinate, starting y coordinate. I'll also pass board. I'll also pass answer, in which I'm going to store them. And do I need to pass words? I don't need to. I'll simply pass a node, and that node is gonna be, what should I make the node? I can simply make a node here, and that node will be node is equals to root, or no, not actually. I have to make root here. Can we pass actually the root there itself? We'll store root here, and we'll again and again pass node. And I think this is pretty much enough to pass. And after this, we'll just return answer, because our function is actually a void function, so it will not return anything, it will just fill in. So we have int of I, int of j, we have vector of character, that is board. We have to pass all the vectors by reference, vector of string of answer, and a node. Okay, so first of all, so I'll check if I is like we can also pass m and n, just for like not writing pretty much stuff, m n. So if I becomes m or j becomes n, then simply return. If anything else, int we can also like create a visited vector. Now this is like a bit why do we need to create a visited vector? Because like it is said the letter cell may not be used once again in the word. So let me create a visited vector. Now this will track whether the current index has been used or not, and this visited will have like size same as the board. Vector int, actually it's boolean vector, because I'll just store false in them. So I've made a visited vector of size m cross n, and I've stored false in all of them. So all of them are not visited currently. When we'll visit them, we'll mark them true. Okay, so I'll pass that also. So there are too many parameters passed into the function. Actually this question is very implementation heavy, I think so. Vector of boolean and visited. So if simply we can check if it is already visited, I mean if visited of ij is true, then we can simply return. We do not need to come on to this index. And there's one more thing, we can simply check if the node does not contain, the current character, board of ij. This is like a concept of trie, so if you don't know trie, you won't understand this. If node does not contains the particular key, then we can also again return. Now we can simply mark visited of I j is equals to true. So this is like visiting an index. Then we have DFS of I plus 1 j board. So we are going in basically below. We are going below. We have to choose all the 4 neighbors below, up, right, and left, because there is said now all the adjacent cells. Now you cannot take like the diagonal cell. Yeah, you cannot take the diagonal cell, but you can take the horizontal and vertically adjacent cells. So there is board, then there is answer, then there is node again. Actually, before sending node, we have to get that node. Now this is again a concept of trie. If you don't know about trie, then it's not gonna like click to you. Then there is node, then there is m, then there is n, and then there is visited vector. Now this is going down. I'll now copy paste this, because I'm not gonna write this 4 times. I plus 1, there was I plus 1, then there is I minus 1, then there is j plus 1, and then there is j minus 1. So this was going up, this is going right, this is going left. After going everywhere, just mark visited of ij is equals to false, and this is backtrack. So what we did is we visited an index, then explored that index, and then backtracked. And what we will do is we can do just one thing. we can check one thing. See, we have two functions, right? Set end, that marks whether a particular word has like ended on this spot or not, and we have a function that marks like that whether a function what is the node value, basically a word has ended or not. Sorry, but I have not created a function that is very required, and that is insert function. Insert function that actually stores all of them, like the words oath, pee, eat, and train, into the trie. So I have to create that word also. Sorry, and this is string of word. I'll also pass it through reference. How to insert a word into a trie. Now, again, you need to know about trie. I'll just do this for character ch of word. Now what I've did is I've set end. Now what does set end usually do? It marks the end of a word, but I'll also store that word. Now this is required. I'll tell you later why this is required, but I'll also pass a string into this. So this is still a void function, but we'll pass a string, and this string is word. And what we have to do is this is also a string. We have to return a string. So set end, we should connect a string s and s. So each node has three values, like it contains 26 links, each to one character. It contained a flag. Now it also contains a string. Now that node will contain whether a word has ended on that node, and if a word has ended on that node, then we have to store that string. So we'll store that string, and I'll just simply put s is equals to word, and s is equals to word. This is actually, wait. We have to also create a function that returns our string. I've created a function that returns that string that is attached. I can also attach a screenshot after the video, like for explaining how did this try work. But right now I cannot explain that. Sorry. So return s. Simply we'll return s. This returns false. We have set the word. Inside set we have done everything. And I think the single part that is missing is that we have to insert our words into that. I'll run a loop till words of size I plus plus. Then I'll simply insert our words one by one. I'll run insert function for words of I, and then all of them are gonna get inserted into the trie. At the end of the trie, we set the end. In set end, what do? We make flag is equals to true, that a word has ended, and which word has ended? That is s, that is stored. So what we are gonna check here is, we'll check if is of end. So we are checking if a word has ended here. If a word has ended here, what is end returns? Is end returns whether a word has ended or not. If is end, if a word has ended here, then what we can do is we can simply push answer dot push back our another function. Note that our word, this was our function, note that our word. Now what does this function do? This returns a string that was ending at that particular node. And one more thing, because we cannot store duplicate words into this, so what I'll do is now I'll mark flag as false, like the next time we do not store the same word again. And let me run this. There will be plenty of syntax mistakes, I know. So we have a problem in this function. We have to pass two parameters here, the character to be put and the node in which it has to be like placed. I've passed both of them. Contains key of, okay, so basically the K is capital. Flag is equals to false. Actually it is node of flag. Runtime error, addition of unsigned offset. Wait a second, I need to like check this again. Node length starts s is equals to contains key character ch node get second. We have placed s is equals to word. Word flag or true. It's true. Can't we like do this? I don't think so. String word. Look jaw. Bool is end, string our word. Bool is end, return flag. I think we are missing something. Return flag. Node root public solution root is equals to new node void insert. Pass the string the root character word. If node contains key ch put node get set end, we have to pass a word. Accepts a word. Actually FDFS int ij character of board visited of ij. Node does not contains key, then we can also return if node is equals to node dot get board of ij. Node is end word. Simply do this visited of ij. I plus 1 comma j, I minus 1 comma j, I comma j plus 1, I comma j minus 1, m n visited. Ij is equals to false. String words m board size board 0 dot size words dot size words I vector string answer passed answer into this vector of string node root m cross n visited dfs have to run for every one of them. I don't see error. I just don't see error. Let me ask to the chat GPT. I mean, you will say like you are cheating, but this is not cheating. I'm just not able to spot the error. I'll check. There is like a critical bug. Okay, so I and j can become negative. This is the problem. Shit, bro. Because we are actually subtracting now. I minus 1, j minus 1. That can be error. And like you are searching for a negative index, then it will, of course, like return. Oh, shit. I have to just replace this line with this, and I think this is gonna work. Shit, sorry. Okay, and like yes, this has passed 591 millisecond. Okay, I'll analyze this, but like this is a very optimal solution because we have not wasted our time. We could have like simply formed a word in this. We could have simply backtracked and formed a word and then try to search it in the try, but that would have been slow. So we actually passed a node that tracks in O1 complexity. Like you track a word in O1 complexity. So the only time that we are taking is this is the nested loops and this DFS search. Okay, so like this was suggested, try depth first search and backtracking, and that is what we have done. And time complexity is also optimal, so it's good. Thank you everyone.